So hello, this is a video for our homework one for distributed systems class. So we had a homework where our task was um to check this unreliable banking where we have uh, different type of errors, and we have this server actually very unstable one. So it's actually like imitating an unstable server, not really unstable one. um so and we can also get these logs where we have latency, we have database connection pool, empty error, and also internal server error. So our task was to send requests to uh, this get balance, um, get endpoint, and later also gather all these logs. So I decided to use Python for this task, for the first part of this task when we collect, when we send requests and gather data, because it's actually the most easy one to set up and use. Yeah. So I have this bank reliability Python file. So actually, let's go from where we enter this one. So entering point of this program is when is this one. So we first initialize random number generator because we'll use it. We'll use it. Um, I decided to use it for random delays between requests to make it more realistic. So here what we do, we first create an argument parser. We pass a parameter base. We specify with like base URL, of course. So we specify number of requests using request parameter. We add prefix using out parameter. We then stop sending requests and start uh, downloading and parsing logs. So yeah, we will then of course store in args object, and if no generate flag isn't provided, we generate traffic by calling get balance multiple times. Um, yes, so no generate is use this one. So if it is provided, then uh, we stop. So then we call we hit get balance function. So yes, we have our function. I will show it later what it does and how it works. So um, yes, then we of course let's actually first check for uh, hit get balance. So what it does, it actually returns tuple with count of OK and bad requests. So we have this um, base URL. We also add get balance to get our balance, and we check for success and failure count. So we check also like how we do it. We check status codes. If it's like 2xx, which means that it is like 201, or anything that starts with 2 and ends with like we have this interval between 200 and 300, which refers to successful. So we check it, and yes, if it is between this range, we increment success count. Otherwise, we increment failure count. And also here we have interesting um, jitter sleep. So I decided to include random sleep to make requests more realistic. However, I also decided to run it without this jitter sleep added. So I actually already have my logs like and CSV file run with as output run with this one and without this jitter sleep. Um, so and also I decided to not overload my terminal but print it like after 20 requests. I print it and show it in my terminal. And if we go to jitter sleep, so it's actually a very simple uh, random random number generator which passes this to time sleep function. which is the base one for Python. And what it gives us, it takes some time between requests. So kind of more realistic approach, like what users do with our service usually. Um, yes, yes. So that's about it. And we have fetching logs function, of course. So what it does requests, it uses requests with retries. So as you can see, as I did quite decoupled, like if you can say it this way, partitioned my methods, my functions into different functions, so it will be more easy to understand. Yes, we have request with retry, so it's actually simple a request. So we send request, we have some default values for max retries, timeout, and so on. And yes, so that's how it works. We just simply send request here. So we have, yes, we have talked already about fetch logs, hit get balance, request with retry, jitter sleep. Here we have just simple imports. Actually, I can delete some, I believe, if they're not used. Um, yeah, though VS Code highlights it, it actually works. Yes, VS Code problem. Yeah. So, and also we have this method of parse style line from text. So what we do here, so we actually first initialize empty variables. Um, if briefly talk about it, and then we pass when then we parse um, our errors. So we have several types of them, as I said. We have error database connection pool empty. We have error internal server error. We do not have actually. So I also decided to include um, error, simple error. Maybe we will have. I saw that maybe server will provide any other error. However, no matter how many times I tried, we do not see any other type of errors. So yeah, so you will see in analysis part that it will be always empty for me. I talk about error others. Yes, and also simple safe outputs. So what this code gives us, actually, let's uh, run it. I'm not going to wait till it completes, but yeah, how it works, maybe while I'm showing you. So we have, yes, let me move zoom. Okay, we have the CSV file saved, and we also have these logs. So, yep. Um, yes, should I mention anything here? Most probably no. So, like, yes, simple logs, and then we also have um, error, well, sorry, CSV file, which the thing, the reason I added it because later it will be um, easier to retrieve and get anything from here and so. Yep. So that's about this part. Our what didn't complete yet. Did we use jitter sleep here? Um, yep. Okay. Maybe that's the reason. So coming to analysis part, I decided to use IPYNB, so Python notebook, using Anaconda. So I'm using Anaconda to run this kernel and Jupyter notebooks. So we have some imports here, of course. We have two parsings here. So we we have it for um, yes. So we have it for with delays and without delays. So yeah, I will uncomment later and show you how another one works. Here we just get some get let me actually um, yes, actually, we can remove row log because later I completely uh, decided not to use it. So, mm, yep. So what we can say is we don't need this row log. And we have Windows window um, window duration. So what it does here is so for of course we do not want to um, check for every millisecond or every second how it happens because for statistics we need some duration. So I added this variable here that gives us ability to change it. So we can use intervals of 20 seconds, 15 seconds, or 40 seconds, and even more, whatever you want. Here what we have, we do basic actually retrieval of data from this CSV file. So what we retrieve, we retrieve what we have there, and I decided just to print it. So we have 94% events, error DB pool 26, latency warnings, DB pool errors 500, internal server errors, and so on. And as I said, we do not have any other errors. So here I print some data. I print what I print here. I print some information about latency. So what we have it here, we have 20 latency messages. So we have a mean of 3 seconds, like 3000 milliseconds. We have standard deviation, which is 1.7 seconds. We have minimum of 295 milliseconds, which is actually uh, the only nice, not nice, but it's not okay for minimum. But if it was like 50th percentile or anything like that, it would be great. But no, for 50 percentile, we have 3.3 seconds. For 90, we have 5.0. 95 is 5.2, and 99 is 5.5. Maximum is 5.5, a little more than what we have on 99th percentile, which is actually very, very bad. Having 3.3 uh, as 50 percentile means that, yeah, half of it was worse. Yeah, half of it was better, but the fact that half of it was more than 3.3 seconds proves that our service is terrible. We can also print very interesting statistic of server latency over time. So what we have here, we can say that, oh, at the very beginning it was not so bad, but later we reached more than 5 seconds, and generally we very, very quickly reached a point when our latency was more than 1000, so terrible. Just histogram, again to look at our latency, how it distributed. So generally we have very bad latency. So here we have some more interesting data. For example, I decided to get uh, median response latency. So um, first, of course, we have it in milliseconds, and I converted to seconds. What we have interesting here, so we have successful throughput. Then actually, I decided that we can also get estimation of our service rate. Um, yep. So we also have utilization, uh, and we have some interesting data like uh, what it was. So reliability of our service. Yes, we have it approximately 67%. percent, which is terrible, of course, as well as availability of 71%. Um, yes, of course, we cannot get information about our MTTR or MTBF. So, but we can get information about mean time between error events, which was easy to get, easy to calculate. So I decided to include this one as well. And for us, it was 2.8 seconds. Terrible, of course. Yep. So median response time of 3.3 seconds. Estimated service rate. So using our formula of service rate, I decided to calculate it. For us, it was 1.0 something requests per second, which is of course terrible. Yep. Did I miss anything here? Looks like no. Hmm. Yep. So as I said, we get estimated service rate using our throughput, successful throughput, and also median latency. Yep. So I decided then to draw instantaneous service rate from our response latency. So using our formula. Uh, yep. So we can see that at the very beginning, it was actually a little better, quite good. Depends on our application and our goal, but generally, 3 requests per second. Maybe there are applications that will say that's enough. Most probably no, but anyway, something good, and it immediately drops. So yeah, some number of requests and it immediately gets down. Um, yep. What we also have error rates over time for GB pool empty. Like not such meaningful graphs in my opinion. Yeah, I thought that maybe there is some relationship between when and which type of errors we get, but looks like no. Yeah, we can notice that for sometimes both of them. No, actually, no, no relationship in my opinion here. Maybe with more number of requests and data collected, we will see something, but not here. Yep. So here some statistics of some distribution in pie chart of our success, internal and DB pool empty errors. So totally we can see 139 requests, 94 success, failures in total 45, of which 26 are database connectionable and 19 are internal server errors. And as I said, no other errors. Yeah, overall success rate of 67. Mm, and let's. So as I said, I also did run my code with random delays added between uh, requests. So let's start terminal to be sure, run all cells. And we'll see that in this case, DB pool empty takes the lead. It's highly more than internal server errors. Not sure that it was, maybe it's just how the server works. So I believe it works with just also some random generator and so on. Maybe it shows some realistic way how it works. So here we have some more stable but also increasing uh, rate of our errors, and we have also server rate going down very quickly. Mm, yep, so Definitely not seeing some changes because also if we look at latency, it somehow kind of tries to stay at 1 second of latency, but then eventually also goes up. Yeah, so that's it. I hope this video was useful. Thank you very much for attention.